Finally, on inverse of a matrix, let's take a quick look at the properties of inverse matrix. Now, remember the first thing we note that the determinant of inverse matrix must not be equal to 0, else it will be non-invertible. Now, one key property we want to look at now is this: when the matrix and the inverse of the matrix are being multiplied together, we will have an identity matrix. Okay, that is the product of a square matrix and its inverse in whatever order. Okay, it can also be A inverse multiplied by A will be equals to this. We'll have an identity matrix. Now, our identity matrix, as we've seen in the types of matrix, is a diagonal matrix in which all the elements of the diagonals are unity. All the elements of the diagonals are unity. So this is the diagonal matrix for 2 by 2. Likewise, this is the identity matrix for 3 by 3. Now, with that done, now let us test. Okay, this theorem, is it true? Let's evaluate for that now. Now, the first thing we'll do is let's look at A. Remember this example? This was the first example we had on inverse matrix of a 2 by 2. So for a 2 by 2 now, we'll evaluate A and multiply by A inverse, and likewise we'll evaluate A inverse multiplied by A. Remember, in matrix multiplication, AB is not equal to BA, so we have to take note of that because the order matters. Now, if A is equal, so let's rewrite that, is equals to 2, 5, 3, 8, and A inverse is equals to 8 minus 5 minus 3, 2. Now let us evaluate this. So let's begin with A multiplied by A inverse. So it is by this 2, 5, 3, 8 multiplied by 8 minus 5 minus 3, 2. Now, if you take a look at this now, remember the way we multiply matrix, that's m by n multiplied by n by p is equals to m by p. All right, and now we are using 2 by 2 multiplied by 2 by 2, and the result will be what? A 2 by 2 matrix. So we are looking forward to a 2 by 2 matrix. So let's look at this now. We are looking at the 2 by 2 matrix just as we did before. So column 1 this will be this multiplied by this, column row 1 of A multiplied by the column 1 of B. So that's 2 by 8 plus 5 by minus 3. Okay, and the next step is row 1 multiplied by column 1, column 2 of this, that's 2 multiplied by minus 5 plus 5 multiplied by 2. Likewise, we continue, and we have 3 multiplied by 8 plus 8 multiplied by minus 3, and finally row 2, column 2, that's 3 multiplied by minus 5 plus 8 multiplied by 2. If you're having issues with this, please kindly refer to the video to establish understanding. Now, if you look at this now, we have 16 plus minus 15. Okay, this is minus 15, or minus 10 rather, plus 10. We have 24 plus minus 24, and we have minus 15 plus 16. Now this results into 1, 0, 0, 1. Identity matrix. Amazing. So it's true. It tallies. When we multiply A by its inverse, we will have an identity matrix of 1, 0, 0, 1. Likewise, now let us try the inverse of A multiplied by A. because we know that in multiplication of matrix, the order is very important. So the inverse of A is 8 minus 5 minus 2, 3 and 2 rather, and A itself is 2, 5, 3, 8. 2, 5, 3 and 8. Now let's multiply this out and see. So of course we will know we have a 2 by 2 matrix at the end. So let's begin with row 1 multiplied by column 1. So that's 8 multiplied by 2 plus minus 5 multiplied by 3. Now row 1 column 2, 8 multiplied by 5 plus minus 5 multiplied by 8. Next is row 1, row 2 column 1. Right, so that's minus 3 multiplied by 2 plus 2 multiplied by 3. And row 2 column 2, so we have minus 3 multiplied by 5 plus 2 multiplied by 8. So in simplifying this now, we can see that we have 16 plus minus 15, just like we had earlier, and this is 40 now. 40 plus minus 40. Okay, we have minus 6 plus 6, and we have minus 15 plus 16, and this results into an identity matrix of 1, 0, 0, 1, a 2 by 2 identity matrix. So now we can come to a conclusion that A multiplied by A inverse is equals to inverse of A multiplied by A, which will result into an identity matrix. Now before we end close up on inverse, finally let's apply the same principle for a 3 by 3 matrix. Are we going to actually get an inverse when it's 3 by 3? Yes, we will. So let's copy this now. Okay, and we'll try to perform the operation of multiplying inverse by the matrix itself. So which other order we get? We have already verified that which other order we used, we will arrive at the identity matrix. So let's go with A inverse multiplied by A. That's 1 over 28 multiplied by 2 minus 4, 7, 22 minus 16, 7, minus 6, 12, and minus 7. Okay, and we were multiplying this by 1, 2, 3, 4, 1, 5, 6, 0, 2. Now don't be scared, all is just 3 by 3 matrix multiplied by 3 by 3 matrix. So if 3 by 3 multiplies a 3 by 3, the result will definitely be a 3 by 3 matrix. So let's go about this. Remember, 1 over 28 is just a scalar multiplier. All right, so let's deal with this first. All right, so we have 1 over 28 outside, since we are dealing with it later. Okay, let's put enough space. We are going to a 3 by 3 matrix. So we'll begin with the first row multiplied by the first column. So we have 2 into 1 plus minus 4 into 4 plus 7 into 6. Now the first row, the second column, we have 2 into 2 plus minus 4 into 1 plus 7 into 0. And first row and the third column now, 2 into 3 plus minus 4 into 5, okay, plus 7 into 2. Good. Now with that established, now we do for row 2. So 22 into 1 plus minus 16 into 4 plus 7 into 6. 22 again, that's for row 2 column 2, plus minus 16 into 1. Right, let's be very careful of what we write. Plus 7 into 0. And finally 22 into 3 plus minus 16 into 5 plus 7 into 2. And now let's do for row 3. Minus 6 into 1 plus 12 into 4 plus minus 7 into 6. As row 3 column 1. Now let's do for row 3 column 2. Minus 6 into 2 plus 12 into 1 plus minus 7 into 0. And finally for row 3 column 3 now, we will have minus 6 into 3 plus 12 into 5, and this will result into plus minus 7 into 2. So resolving this all together now, we have 1 over 28. When we perform all the mathematical operations, here we have 28, 0, 0, 0, 28, 0, and 0, 0, 28. Now that we have a matrix, this is a scalar multiplication now, and in scalar multiplication, we know that k multiplied by a term of the matrix is kij itself. Kaij rather. So this will be 28. 1 over 28 multiplied by 0. 1. This will be multiplied by 28. So this term will multiply all the terms, and it goes like that. So we can just have a shortcut instead of going all the way and multiplying 1 over 28 by all the terms. Since we know that this 1 over 28 multiplied by 0 will all result into 0, so we just leave it like that, and we just deal with the terms, the diagonal terms. So this will give us 28 multiplied by 1 over 28, 28 multiplied by 1 over 28, 28 multiplied by 1 over 28. So we have 0, 0, 0, 0, and 0, 0. Now the result of A inverse multiplied by A will be 1, because 28 divided by 28 is 1. 0, 0, 0, 1, 0, 0, 0, 1, which is an identity matrix of 3 by 3. And in the same vein, if you have A multiplied by A inverse, that is, if we have 1, 2, 3, okay, 4, 1, 5, 6, 0, 2, multiply it by 1 over 28, that's A inverse of 2 minus 4, 7, 22, minus 16, 7, and minus 6, 12, minus 7. If you have this, the result will still be an identity matrix. Now we have come to the conclusion of inverse of matrix, and we know that whatever order of a matrix multiplied by the inverse itself will give an identity matrix, and this can also be the inverse multiplied by the matrix.